13 nonillion dollars. That's 13 with 30 zeros after it. More money than has ever existed in human history. A planet made almost entirely of diamond. Scientists at Yale University announced it to the world in 2012. The media went insane. And then, exactly 1 year later, another scientist checked their math and found a problem. Let's go back to 2004. Astronomers discovered a planet orbiting a star called 55 Cancri, 40 light-years away in the constellation Cancer. They called it 55 Cancri E, and from the moment they found it, they knew it was bizarre. This world is twice the size of Earth, but 8 times heavier. It completes one orbit around its star in 18 hours. That's right, a full year on this planet lasts less than 1 Earth day. The surface temperature is 2100 degrees Celsius, hot enough to vaporize rock. For years, astronomers studied this superheated, super-dense world, trying to understand what it could possibly be made of. Then, in 2012, a team led by Niku Madhusudan at Yale University had an idea. They looked closely at the parent star, 55 Cancri, and they noticed something remarkable. The star was rich in carbon, much more carbon than oxygen. This was unusual. Our sun has more oxygen than carbon, but this star was different. And that's when Madhusudan's team made the connection. If the star is carbon-rich, the planet probably formed from carbon-rich material too. And when you take carbon and subject it to enormous pressure and heat, the exact conditions on 55 Cancri E, something extraordinary happens. The carbon atoms rearrange themselves into the strongest structure in nature, diamond. The team calculated that up to 1/3 of the planet's mass could be pure diamond. The numbers were staggering, between $1 and $13 nonillion worth of diamond. The announcement made global headlines. Diamond planet discovered. It was the treasure of the cosmos. There was just one problem. The math was wrong. 1 year. That's how long the diamond planet hypothesis lasted before someone questioned it. In 2013, Johanna Teska, an astronomer at the University of Arizona, decided to independently verify the Yale team's work. Not because she thought they were wrong, just because that's what scientists do. They check each other's work. Teska focused on the parent star, 55 Cancri. She used a technique called stellar spectroscopy, essentially analyzing the light from the star to determine what elements it contains. And when she ran her analysis, something didn't match. The star didn't have as much carbon as the 2012 study suggested. In fact, it had about 25% more oxygen relative to carbon. Now, 25% might not sound like a huge difference, but in planetary chemistry, it changes everything. Here's why. Oxygen is greedy. When oxygen is present, it bonds with carbon, forming carbon monoxide and carbon dioxide. That oxygen essentially locks up the carbon, making it unavailable to form diamonds. Less free carbon means fewer diamonds, maybe no diamonds at all. Teska's conclusion was careful but clear. The original diamond hypothesis was based on an incomplete picture of the star's composition. The planet might have some diamonds, sure, but probably not enough to justify calling it a diamond world, and definitely not worth $13 nonillion. So what went wrong? How did Yale's team make this mistake? The truth is, they didn't really make a mistake in the traditional sense. They made the best hypothesis they could with the data available at the time. Measuring the precise composition of a star 40 light-years away is incredibly difficult. The 2012 measurements were accurate within their margin of error, but that margin was larger than anyone realized. When Teske used more refined techniques and cross-checked with additional data sources, she found something the first team had missed.
This is how science actually works. Someone proposes a hypothesis, someone else tests it. Flaws are found, the hypothesis gets revised or discarded. It happened fast here, just 1 year, but that's actually a good thing. It means the scientific process is working. The mistake wasn't discovering the error. The mistake would have been ignoring it. But here's where the story gets interesting. Tesca didn't prove the planet isn't made of diamonds. She proved that we can't be sure it is. The hypothesis isn't dead, it's suspended, in limbo. We simply don't know what 55 Cancri E is really made of. And that uncertainty, that's what makes this planet even more fascinating. So if we can't trust the star's composition to tell us what the planet is made of, how do we actually find out? The answer is we look at the planet itself. And right now, the most powerful space telescope ever built is doing exactly that. The James Webb Space Telescope has been observing 55 Cancri E. In 2024, Webb detected something unexpected, signs of a possible atmosphere. This is huge. If the planet has an atmosphere, it tells us about the surface conditions. If it doesn't, that tells us something too. Webb is measuring the planet's temperature distribution, analyzing the light that passes through any atmospheric gases, looking for chemical signatures. Scientists expect to have much clearer answers by 2027 or 2028, and those answers might surprise us. Maybe there are diamonds, but only in certain layers. Maybe the planet's interior is graphite instead, carbon in a different form. Maybe it's something we've never seen before, a new type of world that challenges our understanding of planetary formation. And that's what makes this story so compelling. We started with a $13 nonillion treasure. We ended with a question mark. But the question mark is actually more valuable than the treasure ever was. Because every time we discover we were wrong about something, we get closer to understanding what's actually true. That's not failure, that's progress. Science isn't about being right the first time, it's about being willing to check your math, and when the math doesn't add up, being brave enough to admit it. 55 Cancri E might not be worth $13 nonillion, but it's worth something more important. It's teaching us how to ask better questions about the universe. A planet with an 18-hour year, scorching temperatures, and a composition we're still trying to understand. In a couple of years, we'll finally know what it's really made of. If you want to be here when we get those answers, subscribe to Dr. Black Hole and hit the notification bell. We'll be following this story as new data comes in from James Webb. And drop a comment. What do you think 55 Cancri E is actually made of? Diamond? Something else? I want to hear your theories. See you in the next one.